This video is going to show you the restoration of the Rockwell Collins 618T-3. The 618T-3 is an HF single sideband avionics transceiver used in aircraft. It was developed in the early 60s and it was sold all the way into the 80s. I have another video where you can see this particular radio while it has not been restored yet, but it works and was repaired at that point. I first repaired it, then aligned it, then restored it. This video is going to be about the restoration process. The radio requires a couple of accessories to be operational. Of course, there is the control unit, remote control unit. There is a 400 Hz, 110 volts AC generator, an inverter to generate the voltages for the servo motors inside the radio. And of course we need a speaker and we need a microphone. Microphone and speaker can be plugged in on the front, which is what I did. Can also be connected through the wiring harness. Of course the whole radio sits on a mounting tray. That also was restored also. I did that a while back. This is a recent restoration. This radio is one of the most iconic radios that Collins ever designed. It looks like a simple black box, not very impressive to look at. You know, not like the more nice base stations with all the meters and knobs and you name it. But in terms of the technology, this is one of the most innovative radios Collins has ever designed. And the radio was a huge commercial success. They were used by the military, they were used by civil aircraft, mostly larger aircraft. The Boeing 747 had two of them. And like I said, it was used all the way in the 80s, and then it was replaced with the 618T, which I also show at the end of this video. But like I said, this is a video about the restoration of the Rockwell Collins 618T-3. Okay, we basically disassembled the whole thing to clean up and refinish. As you can see, the finish is really needed on this one. Took out all the modules. Those will have to be cleaned and checked for problems. And of course we're gonna finish the top and the back as well. Took off a lot of stuff, as you can see. This is the switch control that has to, the control board that has to be slightly finished as well. It was in fairly good shape. This is the little fan, that little bugger that makes so much noise. Hard to believe when you see it. It is in very good shape still. Runs very smooth. So that's what we're gonna do. The antenna relay needs to be cleaned. I already cleaned these end connectors and these BNCs because they were all black from silver oxide, so that's gonna look nice. So here we have the front panel stripped from the old paint, and we have the switches and pots cleaned and relays. So now we gotta tape it up with masking tape, and then we're gonna do the spray painting. Okay, we got the front stripped, and we got the electronics taped off. I also sanded the case. So now we have to degrease this, and then we're gonna spray paint it with the original wrinkle varnish. That's done. We got the top spray painted with the wrinkle varnish. Came out nice. The next step is to do the case itself, so it's basically a two-phase process. Had it all taped off now, so we can start spraying the remainder. We got the case done, front and case and back. Looks nice. I removed the tape, and here you can see how it actually came out. This is still without the paint, and now we're gonna rebuild this again. I did finish this too. Don't have a video of that, but that also looks like new again. So let's start with building it up. Everything is back in its original location again, and we can basically finish the assembly. Okay, we put the handles back on. The ID plate, as you can see, it is a Rockwell Collins version that is a late model. I still need to clean the BNC jumpers, but I'll do that later. But we are finished with the assembly of the whole, and it looks kind of nice. Nice paint. And then it basically is a matter of putting this on it again, and then it starts to look like a 618T. Here we got something neat. I ordered that a long time ago, and we're now going to use it. This is a brand spanking new front cover, and we're going to put that on our restored 618T. The front cover I have on there is already pretty nice, but we'll save that for another version, another radio. I got more of them. And this new old stock front cover is going to be on our restored radio. This is the block diagram for the RF translator. You get either 500 kilohertz IF in or 500 kilohertz out in the case of the receiver or transmitter. So here are the transmit mixers, the receiver mixer. The VFO runs from 2.5 to 3.5 megahertz in steps of 1 kilohertz and is corrected, is phase locked by the Kilohertz Stabilizer. So it's basically a VCO, if you want to call it that. Then we have a variable IF filter that covers 2 to 3 megahertz. And is corrected by the auto positioner with the slug rag. And then we either go straight to the transmit mixer, our receiver mixer, which yields us the operating frequency, and that is the case from 7 to 30 megahertz. If we select a frequency from 2 to 6 megahertz, then there is an intermediate stage where a 17.5 megahertz oscillator is mixed with the signal. The reason they do that is to keep the HF oscillator, which is also phase locked, in a certain range. The designers didn't want that to be outside a certain range. First I thought it had to do with image rejection, but that's not the case. It has to do with the fact that the oscillator here needs to be within a certain range. Like I said, from 2 to 6, that is mixed with the 17.5 megahertz oscillator, fixed frequency, which is also phase locked. If you select a frequency from 7 to 30, then that is bypassed. And like I said, here we have the output frequency from 2 to 30 megahertz, which then of course drives a power amplifier, or basically goes to the receiver antenna. So again, this is the RF translator, and that is all done with tubes. So everything from 500 megahertz to 30 megahertz, 500 kilohertz to 30 megahertz, all that is covered with tube technology. And on all the lower frequencies, that is all transistor technology, early transistor technology. Here is the RF translator. This is the unit that is all done with tubes. As you can see here, hollow state. These are all tubes. What you see here is the VFO, variable frequency oscillator, runs from 2.5 to 3.5 megahertz. This here is the auto positioner for the kilohertz steps. As you can see, this one has a date code, this motor here, this miniature motor, 7616, so that is a very late model. I think this must have been one of the latest produced actually. What you see here is the slug rack for the first IF, variable IF, that runs from 2 to 3 megahertz, and that is tuned by the auto positioner. So there is a motor here, and there is another motor that you can't really see underneath there. What you see here is the housing for the turrets. Every 1 megahertz step has its own coil set, and that is underneath here. You can't see it, but there are basically 29 positions for the RF states turrets, which are either used by the transmitter or the receiver. And the output of that, or the input when it is in receive mode, is on this side. These are basically the tubes that drive the pre-driver and the driver that drive the 4CX250 power amplifier. Now I have fixed all these mounting screws. They are like new again, because you know, these service technicians during the lifetime of this radio, they screw those things up. This is one that I have not treated yet. It looks like really bad. You know, I like this thing to look almost like new again. So what you do is you put this in a vise, you hammer this flat with a good straight hammer. Soft tapping actually, not really hammering. So all these burrs are moved back into the Phillips cross. And then you dip it in red paint, and that is then baked in the oven for a while, so that it becomes real hard, and then you have this like new again. So I've done that for all modules, not just this one, to make this radio really look like new. This is the Kilohertz Stabilizer. This is the case for it, cover for it. This is an early model with germanium transistors, and here we have a late model with silicon transistors. Now this unit is where the magic happens. This basically corrects the VCO within 1 kilohertz on the correct frequency. It would take too long to explain how it does that. It is pretty complicated actually. It does that by 2 filters that are underneath here, and a spectrum generator, 2 actually, and a complex mixing scheme such that only one of those generated spectral lines fall into the narrowest filter, which is a crystal filter, and there is another mechanical filter in there which is for the 10 kilohertz correction. 10 kilohertz for correction is done with the frequency comparator, and the 1 kilohertz is pulled on frequency with the phase comparator. Now when you get a radio like this after so many years, one of the most common problems that you have is that the frequency is off by 1 or 2 kilohertz, and that has to do with the digit oscillator. You need to set the frequency such that there is, the last digit is a 5, then you tune the digit oscillator to 305 kilohertz with this adjustment, and then you set the dial for something that ends at a 6, and then you set this adjustments at 296 kilohertz. If you do that, you mostly get the radio okay again. Those are the two critical settings that might have drifted over time. And when you set that correctly again, usually if the rest of the radio is okay, it will pull in the right frequency at exactly the same 1 kilohertz step. Now if that still doesn't solve the problem, then you have probably an adjustment to make for the bias adjustment for the VFO. That's actually so in this module. I showed you the VFO for the RF translator, but the bias for that is here, and that is a setting that's a bit more touchy, but that would probably be your next step if you still can't get it right. The spectral generators are usually still okay. I have never had a situation where you had to correct those. If you have to, it's not too difficult. But like I said, the digit oscillator is really the one that is most critical, and that might have drifted over time. Here a quick shot of the bottom removed of the RF translator. Here you see the turrets I was talking about. Each megahertz segment has its own adjustment for each of the turrets. And here is basically all the switches. This is the RF oscillator that switches the different megahertz bands. So each megahertz has its own coil that is locked to the master oscillator. If you ever have a radio where one of the bands doesn't work, I had that actually with this one. The 18 megahertz wasn't working, and it turned out that the coil, you can adjust them here, that the coil was not locked to the frequency standard. And when I adjusted it by listening to the oscillator frequency until it fall into lock using my ham radio, I noticed that the lock is a very narrow point. So I can imagine that when you have a radio like this, that lock, more for certain bands, might not be present. But like I said, it's very easy to set. You look in the manual what the oscillator frequency is for a particular band, and then you just listen on your ham radio until it falls into the lock. See the top side of the RF translator with the cover removed, so here you can see where the turrets make contact for each 1 megahertz segment. Here you have a very late model. It's a Rockwell that is pretty much one of the last ones made. This is the AM audio amplifier. Contains the mic amplifier as well as the AM demodulator and the crystal filter for the 6 kilohertz AM. Now these are actually one of the best mechanical filters that Collins made. I like those models. If you have an earlier model KWM2 or 2A, it also has that filter. The later ones have the plastic filter. Anyway, so this is the this is one version of it. Here is a very late model. It actually has an integrated circuit, 741 in the audio amplifier, which is the one of the few integrated circuits that were used in the later models. Now, Collins made several versions of this module. Although this does not have the integrated circuit, it is definitely not an early model. I think they made 3 or 4 different versions of that. But the one with the integrated circuit and the different layout, you can see that they use a different PCB method for that, same that they used at later Collins equipment, and even the KWM380 uses that kind of PCB style. Here it is basically with, you know, little rivets going through the boards. So actually I find this a little bit more robust, but this is what Collins did in the later phase. This is another way you can see that this is the later model. It has the blue Rockwell style filter. The earlier filters used the red Collins label. Here we see the Iaf Translator, basically the single sideband Iaf stage. Here you see a 2N78, that's a very old transistor. You can see it's in that oval black housing that is old, but nevertheless Collins used that for a long time until the transistor was not available anymore because of obsolescence. And then they switched in the late model, and those late models are very rare. You know, like I said, even this, although it's earlier, is not particularly an early model. It's a later model, let's phrase it that way. And this was the latest one they did. You can see the changes. The relay has been replaced by some diode ring, and the 2N78 has been replaced by a junction FET, a JFET. And that actually, in both cases, is the AGC amplifier. If you look at the schematic diagrams for the radio, you will see that. So this is definitely a very late model. You can also see that again because of the blue mechanical filters. As you can see, there are two mechanical filters in there, one for upper sideband, one for lower sideband. This one has the Rockwell filters. And this earlier model, although not the earliest, like I said, has the red label filters, but very good filters nevertheless. And as you can see, this particular board is identical to the late model board, so there haven't been that many changes. The big change was really the switch over to the JFET because of obsolescence issues. And again, this is the module that processes the single sideband signals. We're making progress here. As you can see, I have the unit pretty much built up in its restored condition, and I got the modules in there, the Iaf Translator, the power amplifier. Paint came out nice. We got our NOS front cover on it, new old stock, and here you see the modules on the other side. This is the screws that came out nice, all restored, look like new. You can't see it, but the same restoration I did on the screws and all the other modules. And the unit is equipped with as much as possible the late model modules that I had here. So what I still need to do is the covers, but we can run it without and see if it all works nice. But the unit came out good. I like it. What was left was the covers to spray paint with our wrinkle varnish. Well, they are basically done already. The tape needs to be removed, but the paint came out nice. I'll show you the type of paint that I used later. Let's remove the tape, and then we can mount them on our transceiver, which is sitting here without the covers, but otherwise restored. So got to clean the BNC jumpers on the rig. This is what they look like, and this is what they look like cleaned. Going back on the radio. I was trying to find a good way how to supply the Collins, the 618T, and I found this to be the best solution. These are relatively compact power supplies. They are adjustable from 24 to 28 volts. They can be put parallel with the jumper. This way you can operate multiple in parallel. They can do 20 amps each, and they run off 100 to 120 or 220 to 240 auto sensing. So you can connect them and they will sense the correct mains voltage and set themselves accordingly. Like I said, I have them in parallel, and this works quite well. This is the input AC, and the good thing about these is that they are whisper quiet. They're obviously switching power supplies, but they do not generate any RF hash. They were designed in Germany, so the quality is good. And like I said, they are not producing any noise whatsoever. Not on the low frequencies, not on the like 2 megahertz, nothing on 30 megahertz. So that's the reason why I'm using them. 3 in parallel, 60 amps total, and it works like a champ. I had originally bought this Chinese power supply. The good thing with this supply is that it can handle the 60 amps on its own. It can be set for 28 volts with this little pot here. Actually quite a nice power supply, but it is too noisy, especially around 21, 28 megahertz. It gets pretty bad, so I decided not to go that route. Problem is you can't really filter 60 amps, you know. There are no filters that can handle that without causing a significant voltage drop. So that's the reason why I decided to go this route. These are not very expensive. I bought them for 50 bucks each on eBay, which I think is reasonable. So that's definitely worth it. We got the covers replaced on the radio. So we are finished. We are finished. This also gives me a chance to show you the rear of the radio. I did not want this to be one of those spray over mods, spray over restorations, not mods. So that's why I removed all these screws before I did the spraying, and also covered off this Canon connector. This is the pin designator. In other words, this tells the radio, this tells the system whether it's a DC or an AC version. So normally if you put this in the mounting, you can only get it into mountings that are set up for DC operation, which is the top hole being open. Now I said this is the infamous Canon connector that everybody's looking for, at least the mating part of it. Hard to find. They don't make them anymore. And this is the tray with the connector, which again is not easy to find, but sometimes they're offered for sale. You want to make it working 618T installation, you will have to find the mounting or at least the connector. Mounting is better, of course. Now this mount was obviously restored by me. I did put this connector in here. There is another one there that goes to the antenna tuner. I have not connected that right now. I'm going to do that later. That's for the 490T1 or the 3. That will then be supplied by the radio itself. It's an auto tuner, but like I said, I have not put that in the installation yet. I will do that in a later phase. Right now we just have it set up for 50 ohms with a separate manual tuner. Alright, let's put the whole thing back into the tray, and then the restoration is done. I already tested it extensively. Everything in this radio works on all frequencies and all bands, on 1 megahertz bands. From 2 to 30 megahertz works fine. Also for the output power. And there we have it, the completed 618T-3, restored, fully functional, in the tray, mounting tray. It is the Rockwell version, late version. It is the T3, not the 3B. You might think that because it's a Rockwell, but it is the 3, the original one. Connected to a 600 ohm speaker. Of course, this is the control box. And here we have the inverter that's needed, 400 Hertz, 110 volts. That is also supplied from 28 volts. Interconnect cable, had to make that myself. You're probably thinking, what's all this loose stuff here? Those are optional connections for an external microphone, external audio amplifier, and the other thing that we have connected on there are these switches, 4 switches to generate a code for the 100 Hertz steps. Now the 618T-3 cannot do 100 Hertz steps, but there is a 3B that can do that. Then you would need to operate those switches to get in between the 1 kilohertz steps. And there is also a 628T that I have that is capable of 100 Hertz steps. It is drop-in compatible, and I will show you that in a different video. Here you see that 628T-3A. Just to whet your appetite a bit, like I said, this video is about the 618, but I will demonstrate this in a different video. Just a quick explanation what Collins did. This radio is much smaller than the 618T. So Collins came up with a retrofit adapter. This thing is basically empty, it only has an interconnect cable in it to convert this connector to the one that the 618T tray understands. So it's drop-in compatible if you put the 628 into this retrofit adapter. And that adapter is a, try to focus here, that is a 999W1A. Probably thinking that's weird, a 1A, because that's the 3-phase version, not the DC version, but that's because I modified this internally to be a 3A version, which is for the 28 volt DC operation. This has to do with ground wiring for the microphone circuit. It is not really important which position it is in, but for whatever reason the B747 had a different grounding scheme there, and this basically takes care of that. Alright, but like I said, we'll show that in a different version, a solid state successor of the 618T that is smaller, but with the retrofit adapter drop-in compatible, backwards compatible with the 618T. I don't think it was done often with the retrofit adapter, that's why this is a pretty rare item. Because these radios lasted a long time, and at the time that they had to be replaced, the mountings were also replaced, so then they just took advantage of the smaller size of this radio, and the retrofit adapter would not be needed. But fortunately I was able to get my hands on one, and we'll demonstrate it later. CQ20, CQ20, CQ20 meters. Alpha Charlie 5, X-ray Papa, Collins, CQ20 meters. CQ20, CQ20 meters. Alpha Charlie 5, X-ray Papa, Collins, over. Alpha India 4 Foxtrot, Alpha India 4 Foxtrot. Good morning. Name on this site is Luke, Lima Uniform Kilo Echo. We're located in Florida, over. That went a little bit too quick for me. What's the name? Bob? Bob, over?
Yeah, Bobby.
Alright, Bobby, okay. Can you repeat your call once more for me? I was too slow in writing it down. I'm not awake this morning, I guess, over.
Okay. I will make sure I got your Alpha Charlie 5 X-ray Papa. This is Alpha India 4 Foxtrot, AI4F. My name is Bobby in Kentucky. You with that?
Alright, Bobby, Alpha India 4 Foxtrot. Okay, yeah, I was a little bit slow in grabbing pen. I am testing a avionics transceiver, an old 1970s transceiver, aircraft transceiver. I was wondering how that sounds over. Roger, Bobby. Well, there is no S meter on this machine. There is no S meter on this machine. But your 5, I would say 5.7 to 5.3, 5.7 is 2 of Baltimore on the frequency, over. Roger, roger. Okay. Your location, can you repeat your location once more, over? I'm kind of losing you, Bobby. Can you repeat that once more, over? Roger, Kentucky, Eastern Kentucky. I got it now. Yeah, the conditions are not great this morning. They're not great this morning. The other problem is this thing has a very noisy blower. It sounds like a jet engine taking off, so that doesn't help either, HI, over. Yeah, okay, Bobby. Well, thanks for coming back on my call. At least I know the thing works. And catch you the next time. Alpha Charlie 5 X-ray, Papa closing with Alpha India 4 Foxtrot. Bye-bye.